Today we're talking about absolute value inequalities. And so I'm going to start with a question for you. Make a number line and label the places where the absolute value of these numbers is less than 5. Well, I know that, at 0, the absolute value is 0, so that's less than 5. And so I would think it would go all the way out to positive 5, and then all the way down to negative 5 also. If I went past 5, the absolute value of 6 is bigger than 5, so that's not going to work. And if I go more negative than negative 5, a more negative number has a larger absolute value. Okay? I'm not going to include 5 or negative 5 because that's where the absolute value is equal to 5. Okay? And we're looking for just absolute value less than 5. I know last time we started with a lengthy discussion of absolute value of x equals 5, so I figured I'd start in the same place today. Over here we've got absolute value of x is greater than 5. Okay, definitely out here where x is bigger than 5. But I feel like it would also work when x was more negative than negative 5, because the absolute value would still be larger. The distance would still be more than 5 from 0. We could write the solutions to these inequalities as an inequality. Like negative 5 is less than x is also less than 5. And over here we would have x is less than negative 5 or x is bigger than 5. We could also write these as an interval. And over here we could say, all right, if it's less than negative 5, it's going to go all the way down to negative infinity. So it's going to start at negative infinity, and it's going to go up to negative 5. Remember, we use the parentheses when we're not including the number. And that's why we always include a parentheses for negative infinity. Okay, negative infinity isn't a real number. Equals is only a relationship that's defined between two real numbers. So since x could never equal negative infinity, we use an open parenthesis there. Or is union, and then 5 to infinity. Okay, again, not going to include positive infinity, and we're not including 5 because it's not part of our interval of places where the absolute value is greater than 5. Then, if we consider where the absolute value of x is less than or equal to, okay, well, here's the absolute value of x is less than 5, just like it was above, and then less than or maybe equal to. Okay, so for equals, I'll fill in those little circles. And so that's where we get negative 5 is less than or equal to x, which is also less than or equal to 5. And then when we go to write this as an interval, since it's less than or equal to, we're going to use the squared brackets because we're including negative and 5 in our interval. Okay, over here, the absolute value of x is greater than or equal to 5. I'll start with the absolute value of x is greater than 5. And then I'll also consider where the absolute value is equal to 5. Okay, this is x less than or equal to negative 5. This is x greater than or equal to positive 5. If I was going to write this as two intervals, because there's two different places where this is happening. I could say negative infinity up to negative 5. Okay, not including negative infinity, but including negative 5. Union 5 to positive infinity. Okay, the strategy for solving these is going to be just the same as it was last time when we were solving the equations. We're going to start by isolating the absolute value. So we'll get it down to absolute value of something, when this u is just some algebraic expression. We'll have an inequality sign and we'll have a number. Okay, Okay, then we're going to do some number line analysis. We're going to go on a number line and say, okay, this is where the absolute value of a thing is, say, greater than 10. And then we will look at the intervals that we shaded on our number line, set up inequality or inequalities, and then solve. Okay, and after I do a couple, I'll go back and I'll kind of look at it in terms of our strategy. All right, so we're starting with absolute value of 2x plus 3 is less than or equal to 5. Okay, the absolute value is already isolated, so I'm going to go to the number line. And then you kind of ask yourself, where is the absolute value less than or equal to 5? Well, it's going to be between -5 and 5. This is where the absolute value is less, and this is where it's equal. Okay, so we set up inequalities. -5 is less than or equal to this thing, which is less than or equal to 5. Okay, so we put in that thing. I'm going to start by subtracting 3 from all three sides of this inequality. Okay, that's -8, less than or equal to 2x, less than or equal to 5 minus 3 is 2. Then I'm going to divide all three sides by 2. So I'll have -4 is less than or equal to x, which is less than or equal to 1. And if I needed to write that as an interval, I would write that, -4 to 1. I'll let y'all try the one on the right. This absolute value of 4x minus 3 is greater than 5. Okay, I'm going to freeze the screen. If you're watching at home, I'm going to pause the video, and then it's going to flash up with the answer real quick, so make sure you pause the video. Okay, so there you go. Started off, the absolute value is already isolated, so I jump to the number line. I say, where is the absolute value of a thing bigger than 5? Okay. When it's bigger than 5 or more negative than -5. Okay, so I set up those inequalities to match that. I solve the inequalities, and I give a solution. Okay, here we've got another one. We're thinking, where is the absolute value of this thing less than -3? Am I seeing it? No. Yes. Okay. No is a interesting response. Yeah, it's not going to happen. Okay. The absolute value of the thing we talked last time when we were solving the equations, the absolute value can't be negative. So this is not possible. Okay, the absolute value of 7x plus 2 can't be negative, so it certainly can't be less than -3. Since it can't be less than 0, it could never be less than -3, and we conclude that there is no solution. Okay, and that one leads us into our discussion of the 4 really special cases. We just looked at the absolute value of a thing is less than 0. The absolute value of a thing can't be negative. So this one's going to give us no solution. What do we think about the absolute value of a thing is greater than or equal to 0? What kind of views have absolute value greater than or equal to 0? So if we think about anything, it's going to have an absolute value greater than or equal to 0. Okay, so this would be, u could be anything. So this would have a solution set of all real numbers. When I think about the absolute value of u is less than or equal to 0, well, I know that it can't be less than 0. Less than 0 is impossible. So this really just breaks down to the case where absolute value of u is equal to 0. which we said last time only happened when the thing that we were taking the absolute value of was 0. Okay, the fourth one is maybe a little more subtle. Okay, the absolute value of a thing is positive. That's going to be true almost always, right? You take the absolute value of a number and it's going to come back positive. It's not going to be true when you take the absolute value of 0. Okay? So as long as u is not 0, as long as the absolute value of u is not equal to 0, this will be true. But that happens when u is not 0. Okay? So we'll see at least one of all of these cases here in a few minutes. All right, so these are just some more examples, and we're going to attack them the same way that we did the rest of them. We're going to start by isolating the absolute value, so I'll have 2 absolute value of y's is greater than 1 minus 3 is negative 2. Then I'll divide by 2, and I'll have absolute value of y is greater than negative 1. Think to yourself, once you got the absolute value isolated, you go to do number line analysis. You say, what numbers have absolute value bigger than negative 1? All of them. Okay, so this is all real numbers. And so any value of y, you take the absolute value of it, and it's going to be greater than negative 1. Over here. Oh, I know where this is headed. So I'm going to start by subtracting 3. And then you go to the number line. And you say to yourself, okay, where is the absolute value less than 7? It will in here, where the distance from 0 is small, but not including 7. So then you set up for the inequalities, and you get negative 7 is less than 2 minus 5x, which is less than positive 7. And then we're going to try to solve for x. We're going to start by subtracting 2 from both sides. So that'll be negative 9 less than negative 5x less than 5. Okay, and then we're going to divide all 3 sides by negative 5. So I'll have negative 9 divided by negative 5 is positive 9/5. And I'll have 5 over negative 5 is negative 1, and I'll have x. But what do I need to do when I divide both sides of an inequality by a negative number? Yeah, I need to reverse the direction of the inequality. So it's going to be like that. And this is a way that I generally don't write inequalities, right? We tend to go least to greatest. We read left to right. But this is still true. X is greater than negative 1 while being less than 9/5. So what I'm going to do, I'm just going to rewrite it in least to greatest order. So negative 1 less than x is less than positive 9/5. And the other reason I like to write it like this is that if we need to write it as an interval, which you may in order to, recognize the correct answer on a multiple choice test or something, you could say, okay, this is negative 1 and up to 9/5. Because if you'd written 9/5 to 1, that wouldn't make sense because 9/5 is not less than 1. And we always write intervals with the lesser number on the left. Okay, this next one, let's see where this is going. Okay, so we're going to start by isolating the absolute value. And negative 2 plus 7 will be like 7 minus 2, which is 5. And then I'm going to say, where is the absolute value of a number greater than or equal to 5? Well, definitely out here. If I went 5 units from 0 in the other direction, I could have a distance from 0 greater than or equal to 5. Okay, so this gives me something is less than or equal to negative 5, or that same thing is greater than or equal to 5. So it's negative 3x plus 2, negative 3x plus 2. And I'm going to subtract 2 from both sides of both inequalities. and then I'm going to divide by -3. And again, when I divide by -3, I need to reverse the direction of the inequality. And then over here, that would be x is less than or equal to -1. Okay, so if it's less than or equal to -1, that's -infinity up to -1. Okay, less than or equal to -1. Okay, definitely greater than infinity. X is greater than or equal to 7/3 is 7/3 to infinity, including 7/3, not including infinity. This next one is one that they were asking me about yesterday during the quiz, my 8A section, but it seems like nobody was asking me about this today. They wanted to know if they could, distribute that into the absolute value. And it's like, it's best that you don't, is what I'll say about that. I'm not going to say that you can't, but it's best that you don't, because it's just distracting us from what we're trying to do, which is isolate the absolute value. So I've got 3 absolute values of 8x plus 3 is greater than 9. I'm going to subtract 3 from... Wait, no, I've distributed wrong. Yeah, thank you, plus 9. So I've got 3 absolute values of 8x plus 3 is greater than 0 when I subtract 9 from both sides. Then I'll divide by 3, and I get absolute value of 8x plus 3 is greater than 0. I go to a number line. Let's say, where is the absolute value greater than 0? Anywhere where the distance from 0 isn't 0. So out here, sure, over here too, but not 0. Okay? The absolute value of 0 is 0, which is not positive. So what I'm going to say is that as long as 8x minus 3 is not equal to 0, the absolute value of 8x plus 3 plus will not be 0. Or it'll be greater than 0. So if I get that's 8x equals -3, divide both sides by 8, -3/8. This is true for all x not equal to -3/8. And if we had to write this as an inequality, which I really wouldn't recommend, but that would be -infinity up to -3/8, not including either of them, union 3/8 to infinity. Okay, here we have another one of our special cases. The absolute value of 9 minus 2x is less than or equal to 0. Okay, well, the absolute value is never going to be less than 0. So this basically just reduces to the case where the absolute value equals 0, which is right here at absolute value equals 0. So 9 minus 2x needs to equal 0 in this case. And the only way the absolute value equals 0 is if the thing on the inside is 0. So that means that 9 equals 2x, and x is 4.5. Alright, the last thing I've got for you is, here we have f of x equals the absolute value of 2 plus 9x, and g of x is equal to 6 minus 4 times the absolute value of x. So if they ask us to find the values of f of 0 and g of 0, well, over here, if they tell us f of x is 2 plus 9x, and we're trying to find f of 0, we just replace x with 0. So that's the absolute value of 2 plus 9 times 0. Okay, 9 times 0 is 0, so this is the absolute value of 2, which is 2. They ask us for g of 0. G of 0 is equal to 6 minus 4 times the absolute value of 0. Absolute value of 0 is 0, so this is just 6. They ask us to solve the equation f of x equals 0. Well, f of x equals 0, and f of x equals absolute value of 2 plus 9x, so if all three of those things were equal, I could say that this is true. And I know that the absolute value of a thing is only equal to 0 when that thing equals 0. So this is 9x equals negative 2, and x equals negative 2/9. Okay, g of x equals 0 when 6 minus 4 absolute value of x equals 0. So I'm going to try to isolate the absolute value. I'm going to divide both sides by negative 4. So negative 6 divided by negative 4 is 3/2. And I'll say that the absolute value of a number equals 3/2 only when it's equal to 3/2, or maybe when it's equal to negative 3/2. Where is f of x positive? Okay, when we say positive, what we mean is greater than 0. So f of x is greater than 0. So I've got f of x that's 2 plus 9x absolute valued is greater than 0. Okay, the absolute value of a number is always positive as long as it's not 0. So I'm going to say 2 plus 9x is not equal to 0. Okay, because if 2 plus 9x was equal to 0, its absolute value wouldn't be greater than 0, or it wouldn't be positive. So I'm going to say 9x equals negative 2, or I guess it's not equal to negative 2, and x is not equal to negative 2/9. If they ask where g of x is negative, okay, negative means less than 0, so g of x is less than 0. 6 minus 4 absolute value x is less than 0, so negative 4 absolute value x is less than negative 6. I'll divide by negative 4, and I'll get absolute value of x is greater than 3/2. Right? We got to reverse the direction of the inequality because I divided by a negative number. At this point, I think, where is the absolute value greater than 3/2? When am I farther away from 0 on the number line than 1.5? So it's out here and out here. So what I'm going to get is that x needs to be greater than 1.5, or x needs to be more negative than negative 1.5. F of x is less than or equal to 0. Okay, well, the absolute value of a thing is less than or equal to 0. Well, it's never less than 0, so we're only talking about equals 0. Okay, so this is going to just be where 2 plus 9x equals 0. And we already did this up there, so I'm just going to go jump straight to the answer. We already did the work once, no sense in doing it twice. X equals negative 2/9. And then where is g of x greater than or equal to 0? Okay, well, you can't just say all real numbers because g of x is not just an absolute value. So 6 minus 4x greater than or equal to 0 when negative 4x is greater than or equal to negative 6. I divide by negative 4, and I'm going to get x is less than or equal to negative 1.5. No, I lost an absolute value in here. And the absolute value of x is less than or equal to, what? Oh, positive 1.5. In here, and including 1.5 and negative 1.5. So I could write that as negative 1.5 up to positive 1.5. And that's all I've got for y'all today.